the calculus, in the topic of calculus, we basically come across various theorems, of which the Leibnitz theorem is widely used in all the applications related to finding the nth derivative of product of two functions. Leibniz theorem basically is used to find the nth derivative of the product of two functions. Say if I have two functions, u is the first function and v is the second function. The nth derivative of u and v is denoted by uv n, is given by uv n is given by nth derivative of u plus nc1 into un minus 1 v1 plus nc2 un minus 2 v2, goes so on and so forth up to Vn. Here we are basically decreasing the derivative of u and increasing the derivative of v till we cover all possible derivatives in the product. So let us take a small example to illustrate this application. Suppose we are given a function, an explicit function, say y is equal to tan inverse x. Suppose if I differentiate this once, y1 equals 1 by 1 plus x square by the standard rule of differential calculus, and y2 is equal to minus 1 by 1 plus x square the whole square into 2x. Now let us apply nth derivative here in a way that it reduces to a more compact form the product of the two functions. y2 is equal to 1 minus 1 by 1. We are just substituting the value of y1 for 1 by 1 plus x square in the step for finding y2. Or you get 1 plus x square multiplied by y2 is equal to minus 2x y1, or 1 plus x square into y2 plus 2x y1 is equal to 0. So this is, we have brought the product, the explicit function in terms of its derivatives. Now we will be applying nth derivative to each one of these terms by using the linearity rule. That is, we find the nth derivative of the function 1 plus x square into y2 plus nth derivative of 2x y1 is equal to 0. How to go about it? I choose the first function as u, second function as v, first function as u, second function as v. We know that the nth derivative vanishes after a constant. That is the whole concept behind it. So if I take u as the first function, we have 1 plus x square multiplied by, what would be the nth derivative of y2 is the question. So y2, if I differentiate y n times, I will get yn. If I differentiate y1 n times, I will get yn plus 1, one derivative more than n. If I differentiate y2, I will get yn plus 2. So using that concept, nth derivative of the second function will be yn plus 2 plus n into, keep differentiating the first function, so you get 2x multiplied by y n plus 1 plus n into n minus 1 by 2 into 2 into yn. At this point we stop the nth derivative process. Leibnitz rule will be stopped for the first term because we have approached a constant. After the differential coefficient of a constant is 0. So we stop, only 3 terms appear in the Leibniz rule, and then finally nth derivative of 2x y1, applying the same rule, we have 2x multiplied by yn plus 1 plus n into 2 into yn is equal to 0. Now cancelling the terms, we have 1 plus x squared multiplied by yn plus 2 plus 2n plus 2 times n plus 1 into yn plus 1, 2yn plus 1 plus xyn plus 1 plus xyn plus 1 plus yn minus nyn minus
n square plus ny
n square
plus ny.
So we can reduce the given function. We started from y equals tan inverse x, and ultimately in terms of the nth derivative, by applying the Leibniz rule, we derived a more compact result, so which has widespread applications.